Hi everyone, I'm Matteo Ferroni, and it's a pleasure to be here at the Droidcon today. I'm the CTO and co-founder of Bottega 52 SRL. We are an IoT company based in Milano, Italy, and we basically design and deploy production-ready IoT ecosystems. I founded the company almost 3 years ago when I was doing my PhD at the Politecnico of Milano in computer science and engineering. And yeah, I've also been a visiting researcher at the University of California, Berkeley, near San Francisco. Nice spot over there. And I'm a passionate coder. I tried to be a musician once, but it was not good enough. And this is a picture of me pretending I'm surfing, but I'm not able to surf. And I'm assuming you know the title of today's talk. And well, if you thought about this, you probably got the joke, but the good news for you is that this talk has nothing to deal with this. But I've got a bad news for you. This talk has nothing to deal with Android. So this talk is about Internet of Things, cloud computing, and all the fog in between. This talk is about design patterns. It's about the experience I had in the last years of coding, basically. And this talk is about the battles we fight every day. One of the most common battles we fight, and I see people fighting about this, is the one between front-end developers and back-end developers. Just to be clear, when I say front-end, I mean all those fancy user interface, user experience, and stuff like that. This is what users think that is your product, okay? They just think that the user experience, the front end, is your product. But they don't know that there is a monster behind the mountain, okay? That monster is the back end, is the server-side logic, okay? And I'm more on that side. While if you are here, I'm assuming you are more on the client side. Another picture of a real-world deployment. I'm assuming you already know this front end. This is quite common, right? But you'll never know what was behind the scene. That is the back end, okay? So what's the point in here? The point is that here we have some client-side logic. We have some clients that are asking data to a back-end server, okay? So it's a client-server model. It's quite simple, and most of the applications we have around today are built like this, okay? They are distributed applications in the sense there is two main components, and there is an integration point. And you know what? Where we have an integration point, we have a battle. So, sorry, I have some problem with my presenter. If you have a presenter, please give it to me. Thank you. You'll save me. So, this is a picture of my office in a normal day of work. And as you can see here, we have some client-side developer on the left-hand side and some server-side development on the other side. And what I'm quite used to here is that the server's endpoint are not working. You have a problem on that side. But then the server-side guy says, hey, I tested it. It's working. It's your problem, not my business. And on the other hand, you have the data you're sending back are wrong. But maybe you are sending me the wrong input. So finally, it's always like you have a bug in your backend while the other one have a bug in your front end and stuff like this. So the point is that we have an integration point and we have a fight. So what if we add more integration point to our system? What if we add more clients and more servers? Well, we got service-oriented architecture. So someone invented, yeah, whatever. It's okay like this. Thank you. It's okay. So we have a service-oriented architecture in which there are multiple clients and there are an enterprise service bus and middleware communication points with multiple services on the other side. And this is what someone thought was a good idea, and I think it's a good idea, to create an integration layer between services, backend, and clients, frontend. But the point is that the things are getting more complex these days because we have microservices on the hype. Who knows microservices? Cool. I was assuming you were kind of client-side people. So microservices have been introduced by some guys that thought, why don't we just create really small services? And every service has a bounded context. And in this context, the service provide information to the one that uses the service and encapsulate all the logic related to a specific topic. So services are pretty small. Communication mechanism should be quite general and small. And it sounds great because when you see like huge architectures like Netflix and Amazon, these are real picture of real representation of microservice architecture developed by those giants out there. And you think, wow, they are great. I want to build something like this. But you finally end up doing something that's more similar to a big ball of mud. Okay? A big ball of mud is another word to say you have a spaghetti code, you have a Django in your code. And this can be because business making pressure on developers. This can be because you are losing developers because you have a high turnover with your people that are leaving. This is because you are not able to design a system because you need experience. We all need experience to do stuff, okay? So you may ask now, why should I bother? I'm a client-side developer, and you are talking to me about things that happen in the cloud. I don't want to deal with microservices, with service-oriented architecture, server infrastructure, and stuff like that. I'm on this side, and all that complexity is your business, not mine. Well, what about the Internet of Things and fog computing? Are they changing the pattern around? So I'm not here to convince you that the Internet of Things is getting a huge hype and that mobile device era is just the thing before the Internet of Things. And you will get mixed in the whole huge ecosystem. I just took this slide to show you the numbers. Look at the numbers over there. 50 billion of devices in 2020. It's like 3 years from now. 50 billion of devices. How can we connect 50 billion of devices, okay? How can we do this? So someone thought to introduce another layer of complexity. And we have the cloud, we have the things, we have some fog in between, right? So here we comes with fog computing. The idea of fog computing is to bring some computation, some storage, some stuff at the edge of the cloud. You don't want to process everything in the cloud. You want to bring things at the edge because you need some real-time computation. You need to cache data. You need to be closer to the end users. So the point is that if this was the picture up to now with a desktop application, blah, 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 communicating with a server backend in the cloud, now we are adding the Internet of Things, embedded devices connected to the cloud. And then we will add some sensors connected to those embedded devices. But then we may add some fog nodes, some gateways at the edge of the cloud. And then we may add some embedded devices to those nodes. And then add some sensors to those nodes, or some sensors that are pretty smart. We can add them to the cloud directly because they have a GPRS connection, GPRS SIM in them. And here we go with mobile devices. You may talk to the cloud. You may be talking with a fog node, or you may be talking to an embedded device. So yes, maybe distributed systems can be something that you may know something about. So if you think it's not your business, think again, because what service are your application talking with? Are you talking with an IoT node, a fog node, or the cloud? Do you understand the language of the data you are receiving? And are you reading the most recent version of the data? What about caches, for instance? And what about opportunistic networks? We're going to get there in a while. So let's start from a simple business case. Let's assume you want to open a door with a smartphone. Okay, pretty simple. You have a smart lock, super fancy, that is connected to the power, can be remotely controlled, has Wi-Fi connection, and make coffee. And then you'll have your access control system in the cloud. Okay? What is an access control system? It's a system in which a front-end UI can grant or revoke permission to users. So some users can enter a room, can open a lock or not. And basic feature, imagines users, access control list, blah, blah, blah. So you have some front-end, backend, you have an IoT devices directly connected to the cloud, and then you have your mobile phone. And you want to open the lock from your phone. Okay, you are connected to the internet, you have a fingerprint reader, so it's so secure to have a fingerprint reader. You can open a door with your finger, right? Super cool. And then, what do you expect here? Again, client, server, model. You ask your access control system, hey, please open the door. And the access control system knows that he has to open the door. So again, client, server, model. And the smart lock is the client. And keep on asking the server, hey, should I open the door? Hey, should I open the door? Hey, should I open the door? And finally, when it has to open the door, it opens. Okay? Otherwise, it sleeps. Is this good? This is a busy waiting loop. This is something not really good. Okay? So maybe a client-server pattern here is not what I was looking for. Maybe there is another pattern I can learn from. So what about a publish-subscribe model? Here you can use another, for instance, another protocol that is MQTT. Is quite common in the Internet of Things world. So the smart lock now is a subscriber, and the publisher is the backend. So when the mobile application, the client, asks for an open, the server sends a message, because publish subscribe is a messaging protocol, send a message to the smart lock and says, hey, open that door. Okay? It's more similar to the observer pattern that someone explained in the first talk this afternoon in this room. This is quite cool, right? But what if you have a door that is not that fancy? You now have a door that is no cable, is battery powered, Bluetooth connected, and it's really very low power. You cannot connect this thing to the internet, right? So you'll probably want to communicate with that door from your smartphone. Here is a Bluetooth connection. So how can we open the door? For instance, sending a password to the door. Password authentication is pretty simple, right? So the mobile application asks the access control system to have some credential. The access control system says, okay, you are Matteo. You can open the door at this time. Okay, I'll send you the password, right? Send you the password credentials. And now I can open the door using that credential. Is this cool? Is this safe? I don't really trust this guy, because in there you have a mobile device that can be in the hand of a malicious user. Someone may perform some memory inspection. They can disassemble your application. They can do malicious stuff. There can be a zero-day bug in your application, and someone may be able to read the password. What happens? It will happen that that guy is going to open that door whenever he wants. And if that is the door of a hotel room, or your room, your house, that is probably not a good idea, right? So we have another pattern here. We can use like a challenge response authentication. What happens here? We have the smart lock that sends a challenge request to the mobile devices, and the mobile devices needs to ask to the access control system to solve the challenge. This access control system, if Matteo is unable to open that room, of course, will solve the challenge for the mobile application. The mobile application just doesn't know anything about the password. Just pass the challenge and see the solution of the challenge. And so you send the solution of the challenge to the smart lock, and the smart lock opens. So here we go with another pattern that is challenge, response, authentication. And the secret, the password, is not sent. Okay? This is quite good, right? But what if the device is offline? How can I enter my motel room with my girlfriend? So I can cache some credential on the mobile phone, but again, I don't want to do this because I don't trust this guy. I don't know who is going to own that device. I don't know which zero-day bugs will be in my application. I don't want people to do memory inspection on my phone. It can be difficult, but it's not impossible, right? So here we go with fog computing. Let's assume you still have your smart lock that is super very low power, and your smart lock cannot talk to the cloud, but can talk with a local gateway that has Bluetooth connection, Wi-Fi LAN connection. I'm sorry for the price over there. And the idea is that the locks just connect to the local gateway, okay? And it will be the local gateway that has a lot of energy and is more powerful, can talk with your access control system. And the local gateway can be just one gateway for the whole building, for instance, or you may have one for each floor, okay? You can find the right granularity for your problem. And what happens here is that mobile application, here we got a virtual connection between the smart locks and the access control system, thanks to the local gateway that works as a bridge, okay? And here we have the mobile application can talk directly to the local gateway, right? And here, the mobile application doesn't need internet connection anymore because we have a virtual connection between the mobile application and the access control system through that gateway, that fog node. So let's assume this connection now is unreliable because we love seeing integration point fail, right? This connection is unreliable, so we can cache some credentials on the local gateway. Let's assume I booked my motel room and I will be there tomorrow. I can cache the fact that I can enter that room the day before or as soon as I have internet connection for my local gateway. And is it okay to cache credentials, cache passwords now? It's better than before because I trust more the local gateway than the smartphone of the user, okay? Because it's more difficult to go there, broke the local gateway, find the password. Someone will probably block you before, I hope, okay? But let's assume that the local gateway got completely offline. So how can let Matteo enter the motel room with his girlfriend? How can I do this? So here I'm introducing a new concept that is opportunistic networking. Now is the local gateway that exploits the network connectivity of a mobile phone of someone else to send data to the cloud, okay? And here you have a virtual connection. So you are connecting your local gateway not directly with an internet connection to the cloud, but you are exploiting some user's pattern to communicate with the cloud. And the idea is that I will exploit this connection to ask the access control system remotely to give me the most recent credential, the name of the user I have to let enter my motel room, for instance, and I will ask the access control system which are the user that has been banned from entering in that room. And of course, I need to send some logs because I want to see who entered when in my room, okay? But what if the mobile application is not connected? Again, I can exploit opportunistic network delayed. So if you have a mobile device, I'm quite sure that you will connect to the internet maybe in 10 minutes from now, maybe in 1 hour, you will eventually connect to the internet. Otherwise, you don't use an Android phone, right? It's completely useless. So the idea is that I ask the mobile application to send data for me when he will be back connected to the internet, right? So this, again, opportunistic networking, delayed. Quite fancy. We gave a name to this. We call this piggybacking. It's fun. And again, we have a virtual connection. Even if it's not real-time synchronous, it's a synchronous connection. So you may now argue, which is the use case in which you see this happening, right? Let's assume I have a motel, and I have my front end in which people book the room for the next days, okay? So right now, Matteo is booking a room in the motel, and he's coming tomorrow, and tomorrow he has to enter into the room, right? But my local gateway is disconnected. How can I reach that gateway? Look at the definition, if you can. We want to exploit the human social characteristics. So I'm pretty sure that there will be someone that is coming to clean the room before me. So here I'm exploiting human characteristics to bring data around, from the cloud to the fog to the mobile devices to your IoT devices, okay? You want another example of this? Let's assume you have a coworking, right? Today, Matteo just sent me an email asking me, hey, I want to buy some space for the next month, so I'll be there in 24 hours. I want to enter the coworking, okay? And again, you have no connection of your local gateway for any reason. Maybe a broke connection, maybe you don't want to get it connected. Social characteristic. I'm quite sure that in a co-working space, in an office, someone is going to come and clean as before. So just to give some insights of what you can do and what it means to develop systems that are not just client-server, and you're not just talking to the cloud. There may be a lot of layers in between with fog computing and stuff like that, right? So back to our case. Other problems in here. Let's assume someone changed some credential because Matteo has been a bad guy and he cannot enter the coworking anymore. So here I have the main storage of credentials, and at a certain time, a mobile device is disconnected from the local gateway, and the local gateway get connected again to the cloud, and so you send the updated credential to the local gateway, and after a while, another mobile application connects to the cloud and sending old and outdated credential. So here we have a cache coherency problem, right? Because you have to remember which is the most recent version of your data. You have to define some priority. You may say that cloud data is always the most secure. This is quite cool in this case, but may not be the rule for all the possible scenario, right? And let's assume we want to open a door with a smartphone, and you have a fancy door, a fancy lock, and your mobile application. Is this still a client-server pattern? There is something more out there, right? And if you know this quote, I love this quote, no man is an island, entire of itself. Every man is a part of a domain of something bigger. And this happens to software too, because no software is an island. And we are creating distributed systems. And we have to be clear about this. And because integration is everything, a completely disconnected system nowadays is completely useless, because can you see this picture? Of course, we can add a payment gateway. I want to pay every time I enter a room, for instance, because, I don't know, there is a service, physical service over there. So I'm making innovation also in the business model of a certain company. And here, you have to integrate with that. Can be also an ERP, a CRM, some legacy bad code, can be anything, and you have to integrate with that. You have your backend that needs to integrate with that, and you may have also your application to integrate with that. And again, here we have unreliable connection, and the backend can go offline completely. So what to do here? When something happens, I want to notify the external integration point, and I don't want to lose data. So here is yet another pattern. That is idempotent retry, asynchronous. That is pretty simple. The name is more complex than the concept itself. I'm trying again. After a while, I'm increasing the delay. I'm increasing the wait time. Maybe I have a scratch pad in which I sign the things I have to do sooner or later. Okay? So all these integration patterns are really interesting. And you know what? We implemented what I showed you before. Here is Sofia, a smartphone-based and cloud access control system. And we are targeting some different industries, like accommodation, the motel room I was talking before, utilities, smart working, and logistics. We currently have a deploy in the PolyHub coworking in Milano, if you know. Please pass by if you want to say hi. And we are planning to deploy the same solution in other co around Italy and around Europe. We have some partners, of course, because remember, you cannot do everything alone. You need integration. You need partners. And of course, we needed a lock. So, hello, Iseo Serrature. And of course, we needed some gateways. Thank you, Cisco Systems. And of course, we needed the cloud, right? And Microsoft Azure is kind of an opportunity. And Team Working Capital chose us as a good project to invest in. So we have been invested, was 1.5 years back in the days. So some takeaways from this very short talk: apply design patterns and avoid anti-patterns. Because as someone was saying before in this same room, we are not reinventing the wheel every time. Just hire the abstraction and understand how to do things, okay? Because someone already tried to do the same before. Probably not the same market, probably not in the same industry, probably not with Android, Visual Studio, whatever technology you want, but someone probably already did it. And software should be cynical. So bad things will happen. Cynical, okay? You must expect your software to fail, because it will fail sooner or later. Be conservative in what you send and liberal in what you accept. This is the robustness principle. So when you have multiple points of integration, the robustness principle helps you not to fight with people, okay? And every integration point is gonna fail as your software. It's not just your code. I already told this multiple times. It's not just your code. You are part of something bigger, right? And again, to this idea, no software is an island, and no developer is an island. Because we are part of a bigger team, okay? So please stop those useless wars, stop fighting. Client side, backend, frontend, blah, blah, backend, blah, blah. Because we are just fighting one enemy that we have in common. And this enemy is the worst one because he is always right. He pretends your software never to fail. And he will destroy your software. He will destroy your software sooner or later. And I'm talking about end users. So I'm Matteo Ferroni from Bottega 52. This is my company and my life. And yes, we are hiring. Thank you.